Yeah. Uh, in this video, I will explain a problem. There is a problem. This one based on invertible functions. Okay. Okay. Actually, I know that for so many people or students, this solving of this problem is somewhat difficult. Some people struggle to understand this. Okay, I will explain, okay, very nicely at slow pace. Listen carefully. Okay, see, let f colon n to y. So this is a function that defined, be a function defined as f of x is equal to 4x plus 3. This is the function f of x is equal to 4x plus 3, and here f colon n to y means this y. Sorry, once again. This is capital Y, not small. Okay. N to y means y is the output, n is the input. Here n means natural numbers. Natural number starts from 1, 2, 3, it's till infinity. So this is input, this is output, and this function is given by this next point. And they are telling what is y. Okay, y is set of output values, small y is some output. There are many output values. In that we have taken one value, that is in general we have written y, that y belongs to n. That output value also, n means what? Natural numbers, that is also natural number. And that y, the output value will be this 4x plus 3. Y is equal to f of x. F of x can be written as y also in this case. Okay, so f of x, that is equal to y. So y is equal to this 4x plus 3. 4x plus 3, 4x plus 3, same, because f of x, in place of f of x, we can write y. Okay, for some x belongs to n, x is input, that belongs to n. As I said, n means natural numbers. Next, this is the question. Show that f is invertible and find the inverse. We have to prove the function f is invertible, and after showing we have to find what is f inverse. F inverse is what? Okay. So now to solve this problem, first we have to understand what are invertible functions. Okay, see, definition of invertible function. First we need to understand what is invertible function. When you know the definition, then you can proceed what can be done as a solution for this problem. Okay, now, so this is the definition. F colon x to y, the function is defined as x to y, that means y is output, x is the input. This capital letter x, capital letter y is invertible if there is a function g y to x. When we say f is invertible, there should be a function g that is defined as y to x. That means y is the output, x is the input. That means what is here x to y, here y to x. Input to output, here output to input. This function gives output from inputs. This function gives input from output. So that is the meaning. Okay. Then if we have function g, then we will say g will be the inverse of f. So g is equal to f inverse we will write. But with this and this, there is another condition. This one, g naught f is equal to ix. G naught f means we can also say g of f of x. G naught f can be written as g of f of x. Okay, here ix means identity function on x, capital X. Capital X is the set of input values. That's the meaning of Ix. Since here we have capital X, so G we will write here f of x, small x. G naught f is equal to G of f of x. Why this x is because of this capital X. Okay, that thing. Next, another condition, f of g is equal to iy. This f of g can be written as f of g of y. Okay, since we have y here, because of this y, we will take small y, then f of g of y. So f of g, f naught g is equal to f of g of y. Okay. Okay. So this is the definition of invertible function. Using this, we can solve this problem. Now I will explain. So we have seen y set of y values, and we have taken output values. Output. So from this set of y values, we will take some element, say y, some arbitrary element we are taking. Let y an arbitrary element of y. So let y be a arbitrary element of y. Arbitrary means imaginary. Okay, we are imagining, we are assuming the y is a some element from this. We are taking some element from this y. That's the meaning. Okay, remember that. Previously, we have seen. Okay, so they have given y is a, this y is given by small y is equal to 4x plus 3, and this x belongs to n. Same thing I will write there. Okay, so by the definition of y, y is equal to 4x plus 3, because it is given. We have seen just now, I showed you, and it is also given x belongs to n. Okay, we have seen in the previous board. Next to, okay, now come to this. We have conditions. G naught of f is equal to ix. Okay, G naught f means what I have shown here. G of f of x. Okay, G of f of x. So we have condition. We have to show this. We have to prove this. Okay, so this I will write G naught f is nothing but G of f of x, that is equal to ix. Okay, so G of f of x is equal to ix. Remember, this is called identity function on x. Capital X. Capital X is set of input values, and this will be equal to small x. Okay, now we have to prove this is equal to this. Okay, next step, this G will be as it is. Okay, f of x is equal to y, small y. I said this already. So G of y. Okay, so G of f of x means G of y. We have to find this now. we have to find, and that should be equal to this x. First we have to find g of y. For finding g of y, take this function. Okay, so y is equal to 4x plus 3. Okay, now we have to solve for x. Okay, so we want x, so keep 4x term here, send this 3 this side, so it will become minus 3, that is equal to this 4x. When 3 is sent this side, y will be here only, so plus 3 becomes minus 3, and that is equal to this 4x. I said we want x, so divide, we don't want 4, divide both side by 4. Okay, now this 4 cancels out. Now this, we are left with this y minus 3 by 4, that is equal to this x. Okay, so just interchange, send x to this side and send this to this side, so no wrong. So we can write x is equal to y minus 3 by 4. Now in place of x, we have to put this g of y. G of y is equal to y minus 3 by 4. Okay, next. Now take this. Now take this g of f of x. G of f of x. Okay. Now this is equal to g of f of x is equal to this only, 4x plus 3. Y is equal to 4x plus 3. F of x is equal to 4x plus 3. Both are same. In place of f of x, you write 4x plus 3. Okay. We oh, I'm sorry. Once again, I'm sorry. Just small mistake. We found this. Take this only again here. G of y is equal to y minus 3 by 4. Take this only. Next, what you have to do? G of y is equal to asterisk. Write asterisk. So in place of y, we have 4x plus 3. Write that. 4x plus 3. Okay. In place of y, we have 4. I have written 4x plus 3. This minus 3 all divided by this 4. Now 3 minus 3 will become 0, so we will cancel out. Next we will have g of y is equal to this 4x divided by this 4. 4 cancels out, so x. Okay. Now in y and f of x both are same. In place of y I am writing f of x, that is equal to x. G of f of x is equal to x. Ix is equal to x. So we have proved one condition. Okay. See, this condition proved. G naught, see, G naught f, G of f of G naught f is equal to G of f of x. This is equal to x, and this is equal to Iy is equal to small y. So this is proved. We need to prove this. F of g we have to prove. F of g means I already told f of g of y. We have to find this f of g of y now. So f of g of y we need to find. Okay. So f of g of y we have calculated y minus 3 by 4. Write that y minus 3 by 4. G of y is equal to y minus 3 by 4. In place of g of y, I am writing this. I hope we got it. Next, we have to simplify this further. 4x plus 3. So we have y is equal to 4x plus 3. Y minus 3 by 4 and this plus 3, 4x plus 3. So how to find f of y minus 3 by 4? So we have this y is equal to. So y is equal to 4x plus 3, or we can write f of x is equal to 4x plus 3. Okay, it is given. So write this f as it is. In place of x, we have this y minus 3 pi by 4. So that you write. 4. This 4 will be as it is. In place of x, we have y minus 3 by 4. So in place of x, write same thing, y minus 3 by 4. This plus 3 will be as it is. Now that is equal to this 4 cancels out. We are left with y minus 3, this plus 3. That is equal to minus 3 plus 3 becomes 0. So we will cancel out. So we are left with y. So we got this f of y minus 3 by 4 is equal to this y. Okay. F y minus 3 by 4 what? Y minus 3 divided by 4 is equal to g of y. So that I will write g of y. In place of this I am writing this because we have this. Okay. So that is equal to this y. Okay. So second condition also proved. F of g of y is equal to y. This one f of g, f naught g, that is equal to f of g of y, and that should be equal to y, small y. Iy is equal to small y. So we proved. Okay. So we proved two conditions, this one and this one, according to the definition. Okay, now This is definition of invertible function. So using this definition, we have proved the conditions this and this. That means G is equal to F inverse. So according to the definition we proved, we got these answers, this and this. So F is invertible. Function F is invertible. And this G is the inverse. G is the inverse. That inverse G function G is this. Y minus 3 by 4. Okay. Now come to this problem. So in the problem they said, show that F is invertible. Using this definition, we proved this condition and this condition. So that means according to this definition, so F is invertible, we proved. Find the inverse. In the definition, G is the inverse. So we got that G inverse G. So you got it. So according to the problem, we have proved F is invertible, and finding inverse of F is G. The question asked, prove F is invertible. We proved how? Using this definition. We proved this and this, that means F is invertible. So another condition, find the inverse. According to this definition, in the definition we are telling G is the inverse. We found that also. So this problem is solved. Okay. Hey, thank you. Click on subscribe.